The magnitude and direction of two forces acting on an object are 70 pounds south 56 degrees east and 50 pounds north 72 degrees east, respectively. Find the magnitude and direction angle of the resultant force. So some object, and I'm going to think about a little compass around it, right? North, south, west, east. My object's right smack dab in the middle, being acted on by two forces. The first force, south, so south, and 56 degrees east. So my 56 degree angle is this one, right? It's like I'm pointing to the south and I lean 56 degrees over towards the east. All right, the length of this vector, 70 pounds. All right, and then my other angle, north, 72 degrees towards the east. So I start going north and I lean over 72 degrees, so a bigger angle. This is definitely not drawn to scale. So there's my 72 degree angle. And then there's a shorter vector that's only 50 units long, right? Representing a 50-pound force. And we've been asked to find the magnitude and direction angle of the resultant force. Well, that means we need to add the blue and maroon vectors. And so visually, I could think about our parallelogram law. And my resultant vector, not drawn to scale, is this one, right? So I'm looking for that vector's length and also its direction angle, which if I go by the rules of direction angle that we've been using, it'll be that large angle right there. All right, so now let's see if we can go about this. So I'll start with the first force they give me. I'm going to call that one force 1 because I'm super creative. And that is a 70-pound magnitude vector. And now I'm going to think about multiplying by a unit vector, right, to create force 1. And I have this 56 degree angle, and that's not really the angle I want, right? That's not what I'd usually think about as a direction angle. But it's enough information to certainly find it, right? If I rotate from the positive x-axis down to here, that would be 270 degrees. And so 56 degrees more gets me to that vector. So this is going to be a cosine of 326 degrees, comma sine of 326 degrees. And there I have a component form for the first vector. I'm using my vector bracket notation, but I could also think about that as 70 times cosine of 326 degrees I plus sine of 326 degrees J. I'm going to do the same thing for force number 2. That's a 50-pound force. And let's see, cosine, comma, sine here in my vector braces. That's a 72 degree angle. The angle I want to use here, the direction angle, would be an 18 degree angle, thinking about those two angles being complementary. All right, so what I'm going to do now is write down force 1 approximately. So the x component, 70 times the cosine of 326. So that's about 58.033 in the I direction. And let's see, 70 times sine of 326. So let's see, minus 39.144. Now I'm carrying 3 decimal places here, and in the end I'm going to round, I think, just to 1. I didn't write instructions for rounding here, so I think I'll just kind of go to 1 decimal place and let that be good enough. I'll do the same thing for force 2 here, the blue one. So 50 times the cosine of 18 degrees, 47.553, comma, 50 times the sine of that same angle, 18 degrees. All right, 15.451. All right, these are both forces in pounds, right? So this is a x component of the blue one in pounds. This is a y component of the blue one in pounds. So those are forces. My resultant vector, which I'm just going to call F, can be found by adding those two things together. All right, so 58.033 plus 47.553. My resultant vector in the x direction, that I component, 106.586 pounds, and now the y. So I have a minus 39.144 plus 15.451. And there's my j component, the amount of force in the y direction, minus 23.693. Looking at what I have drawn here, right? The maroon vector, positive and down, right? So a positive x and a negative y. The blue vector pointing up into the first quadrant, positive and positive. And my green one, I go over and down. Everything seems really good about this. So now I'm left to find a force's magnitude. So that's going to be the square root of the 106.586 squared plus that minus 23.693 squared. And we can go on and find that magnitude. The square root of 106.586 squared plus 23.693 squared. Not worrying about that minus because a negative squared, of course, is a positive. And here I get that magnitude 109.2 pounds. The resultant force, 109.2 pounds. And now we need to find a direction angle. And so tangent of theta, have an x and a y, so the tangent of theta should be minus 23.693 all over 106.586. All right, so I'm going to use inverse tangent to get a start here. So the inverse tangent would be minus 23.693 over 106.586. And let's see, I get theta is about minus 12.5 degrees. All right, well that would be this angle. I want a direction angle, so I'm going to say that theta, the direction angle, is actually that plus 360 degrees, 347.5 degrees. And there we have it. We have the magnitude of our resultant vector, 109.2, and then the direction angle, 347.5.